Today we're going to talk about input and output tables. Anytime we're talking about inputs and output tables, you can assume that the input is considered to be your X value because we are going to eventually go ahead and graph these. And our output is going to be our Y values. Now, another term for this that you might get into next year, when we talk about input, we're talking about independent variables. And the reason why they're independent is because you kind of choose them. And then depending on what you pick for your input, such as how many cookies are you going to eat, your output is determined. Your output is a dependent variable. It depends on whatever your input is. So how many chocolate chips I consume is dependent on how many chocolate chips are inside every cookie. And if our input is the number of cookies I eat, the output or the dependent variable is how many chocolate chips I would eat because of that. And I'm only using that example because my sister is currently downstairs making cookies. But let's look at these rules. In these rules that we have here, the operation that we're going to be using is adding. A lot of the times in the real world, the rules that we have, we call these the rules, are multiplication problems. And we're going to get into some of those in just a second. But this rule says add 3. So basically what I'm going to do is I'm going to take each one of my inputs, which I'm going to call X. Okay, because our X values are going to change. We're going to change them. And I'm going to take that X and I'm just going to add 3 to it. So when my X is 0, I want to do 0 plus 3. What is 0 plus 3? It's 3. So my output of my Y value is 3. 1 plus 3 is 4. 2 plus 3 is 5. 3 plus 3 is 6. 4 plus 3 is 7. Now I'm going to go over to my other table. We've got our inputs and our outputs, but our rule here is add 6. So I'm going to take my X and I'm going to add 6 to it each time. So you can see that on each one of my X values, I added the 6, which was the rule, in order to get the output. We can also take our input-output tables and create ordered pairs. Remember, our ordered pairs are written in X, Y form. So in my first rule here, when X is 0, when my input 0, my output is automatically 3 because my rule was to add 3 to X. When my input was 1, my output was 4. When my input was 2, my output was 5. When my input was 3, my output was 6. When my input was 4, my output was 7. In my second table, I've got another rule with adding 6. So my ordered pairs are 0, 6, 1, 7, 2, 8, 3, 9, and 4, 10. Now we are not going to get into graphing today, but you could just simply take those ordered pairs, graph them. You would just want to connect the dots of each rule with a different line. So I might say a solid line is for the line for the rule add 3, and a dashed line is the line for the rule of add 6. Let's look at some real world examples here. So first it says, fill in the missing numbers in the tables below. So we're going to compare the number of starfish to the number of legs. Well, I need to figure out my rule. Now this is an example where my pattern or my rule is going to be multiplication. I can assume my input, my X value, is the number of starfish, and my output, my Y value, is the amount of legs I have. Well, what's my pattern? Well, it tells me here that for each starfish has 5 legs. So my rule or my pattern is going to be to take my input, which is the number of starfish I have, and multiply that by 5 because each starfish has 5 legs. So if I had 2 starfish, that would be 10 legs, 3 starfish, 15, and 4 starfish, I'd have 20 legs. If you look down here, this is a graphic organizer that you can use anytime you're dealing with patterns. So in that particular example, or actually I'm going to use my one of the other examples for that one. Let's look at the number of cars compared to the number of windows and the number of doors. So we always look at this, what's called a unit rate. And the reason we call it a unit rate is because for each individual car, you're going to have 8 windows and 4 doors. Well, it says, what's the rule that describes how the number of windows relates to the number of doors? So I'm looking at just the number of windows compared to the number of doors. If I look at my number of windows compared to my number of doors, I have double the amount of windows to doors. So this rule is actually a division rule. I'm going to take my input, my number of windows. I know that that's first because it's listed first in my problem. Compare it to the number of doors. If I take my number of windows, I need to divide it by 2 in order to get the number of doors, or my output. And that works for each line in the table, therefore I know that rule is going to be true. Let's look down at quarts and cups. So we just did these measurement conversions, but these measurement conversions that we do can also be listed at input-output tables. So I'm going to use my graphic organizer down here for this one. Here's my rule. In 1 quart, I have 4 cups. Another way that I can say that is for each one of my x values, I can multiply that by 4 in order to get my y value, which is the amount of cups I have. So I can have my rule as right here, number of quarts times 4 gives me my number of cups. And then you can fill it in. When I have 1 quart, I have 4 cups. When I have 2 quarts, 8 cups. 3 quarts, and again I just take my input of 3, multiply it by 4, I've got 12 cups, 4 and 16. Again, we're not going to go ahead and graph today, but I hope you guys learned a little bit more about input-output tables that goes along with our patterns.